Hello guys, it's me. My name is Alban. I am an IB 45 predicted student, and today I'm going to teach you guys everything about IB physics, the goods, the bads, the so-sos. I'll let you know all the details. So, starting up, what is IB physics? IB physics seeks to answer a central question about what the nature of the universe actually is. It teaches you very multifaceted stuff, and you'll be taught to think in complex ways to combine a lot of different aspects of what you learn together. So, as with many other courses, this is offered at both standard and higher level. You can see there's a 90-hour discrepancy here, which is pretty big. Standard level goes into the core theory for physics, a little bit of practicals, and the IA. Higher level does also that, but it has additional higher level content that goes deeper into the nature of physics, and you tie up more loose ends in knowledge here and there. So, there are three overarching concepts in the whole of IB physics that you will need to know for everything: energy, particles, and forces. These will come up time and time again on every single one of the exams, and they tie in together with the rest of the syllabus quite nicely. Speaking of, there are 5 sections to the syllabus, which I will get into specifically a little bit later. There's space-time and motion, the particular nature of matter, which is the weird name, yeah. Wave behavior, fields, and nuclear and quantum physics. In here you have concepts like kinematics, forces, gas laws, the Doppler effect, simple harmonic motion, all that's pertaining to gravitational, electric, magnetic fields, and some cool stuff about radioactivity, fission, fusion, and stars. Of course, for the AHL people, you have relativity, thermodynamics, a little bit more detailed simple harmonic motion and standing waves and wave behavior. I don't know why I didn't put it there. And electromagnetic induction. Also quantum physics, but we don't talk about it. It's a pain in the butt. Now, let's talk about how time is divided inside of the IB physics syllabus. So, first of all, you have the IA, which doesn't change for both of these. It's an individual research project that counts for 20% of your grade. It's a maximum of 3,000 words. It's pretty nifty. I recommend. There's the practical program as well, which mostly serves for your paper 1B and for the development of your IA. It teaches you stuff like how to operate with different tools, how to process data, what you can do in the lab, what you can't do, and it teaches you how to work with uncertainties, which are going to be really important. There's a 20-hour discrepancy here. Nothing much to add. I feel like HL just focuses on the HL apps, that's it. The syllabus content, though, is the major discrepancy here. You see there's 70 hours between HL and SL. Now, these are all the 5 themes they need to learn, and for HL, of course, you have the AHL things, and revising a lot of the SL stuff later on in the year. To be fair, 110 hours and 180 hours doesn't really cut it, because, as I'll mention later on in this video, this is a pretty challenging course, and you will need to spend more time than what's actually advertised in order to get a 7 or a very good grade. But you got this stuff. Now, the important part here is how to do well in physics. Now, you can't really go into it as a memorization class, because it's really not. What you're being asked a lot in paper 1A, paper 1B, paper 2 is a lot of theoretical understanding and how concepts link together. Secondly, you need to be able to do maths really quickly and really well. You need to avoid these small arithmetic or algebra errors that people usually tend to have while starting off physics. You can tie these up in your first year of diploma, but by the second year they should be mostly gone. Thirdly, you should start past papers early. I kid you not, these are the single best way to learn new things. When you feel like you've stagnated in your reading and you're learning by reading, you should try some past papers. Of course, leave last year's ones for last for second DP, but I guarantee you'll find a lot of things that you thought you knew, but you actually didn't. Fourth, you should take labs seriously, because maybe they don't come up in your 1B exam, but they teach you how to work with uncertainties, with tools, with measurements, and with data in a way that will guarantee you the free marks on 1B. Really recommend. Fifth, you need to make connections actively. This is a course in which everything ties back with one another, and every single 2 topics, or 3 topics, or 4, they can be bound in a single paper 1 or paper 2 question. And exactly also in your IA. And for higher level students, though this can go for everybody that finds the topic difficult, whatever you think is the most daunting topic, read it up now and try to form a basic understanding of it. Of course, not a flawed one, but a basic understanding of it so you can let it sit in your brain for some time. It's always really hard to rush the content and rush your understanding, so give yourself time to think and to let everything be absorbed in your brain before exams. So, talking about the exams, the papers. These are 80% of your final grade. They're a pretty big deal. I'll talk mostly about what's in each paper and then about the discrepancies of SL and HL. So first of all, 1A, it's multiple choice. It comes together with 1B. This one is a lot about operational understanding, a lot about proportionalities, and sometimes a bunch of theory too, which is really nice. One thing about this paper is that you will not get any marks off for wrong answers, so always do answer. Put your X in the formula sheet. In the answer sheet. For SL, there are 25 questions, and the whole exam, paper 1, lasts an hour and 30, and for HL there are 40 questions, and they span over 2 hours. Now, this is kind of misleading. I put this in the 1A section, but it's actually 1A and 1B that come together as an exam. So 1 hour 30 for 1A and 1B for standard level, and the same for HL, 2 hours. 1B. This is what a lot of people find really mysterious. It's not really too difficult, but a lot of people find mysterious. I would recommend you try your hand at this a couple times before your exams. Oh, what'd I do? So, these are database questions in which you need to analyze graphs, tables, and experiments, and you need to reference the data and also be able to think in a really realistic context in order to find improvements for systematic, random errors, and to find the most appropriate tools to conduct an experiment. It's completed back-to-back with paper 1A, and usually time isn't too much of an issue, but you should always pay attention to your practicals because they make this one really easy. Now, paper 2. Paper 2 is 44% of your grade, which is really chunky, I must say. For SL, it's 1 hour 30 minutes and 50 marks, and for HL, it's 2 hours and 30 minutes and 90 marks. I think it's going to be your longest exam in the whole of IB. And these are short response questions and sometimes extended response. Each question will typically only go up to 3 marks, 4 marks if you have a really big question. And they're really divided into different sections that carry well together. There are some really important tips here. You should read and recognize the specific situation before answering because sometimes the IB likes to sneak in keywords at the top. Maybe a transverse or a longitudinal wave. If you can't differentiate between the two from the exercise, you should always read the thing above so you can figure out which one is which and avoid losing easy marks for absolutely no reason. You should show full working always. There's method marks, there's a lot of marks that are given to you if you attempt certain stuff. Hey, there's always stuff to collect. And you should watch significant figures, honestly. The IB doesn't really penalize you for using more significant figures, but you should always try to be spot on. That being said, it's better to have more significant figures than less because with less significant figures, they actually do penalize you. So make sure you study these properly and look at a couple mark schemes. Both of these papers ultimately require a calculator and a physics data booklet. Learn how to use both of these really efficiently because you don't want to be spending time in your exam just punching numbers in your calculator aimlessly. That seems a little bit unorganized, right? So, now going into the IA, which is the other component of the assessment, this one is internal. It's 20% of your final grade and it's a report up to 3,000 words, save for SL and HL, that is supposed to take 10 hours of your time. Usually takes longer. It's divided into 4 different categories. Research design, data analysis, a conclusion, and an evaluation. I won't get too deep into what the internal assessment means right now, but it should be a clear research question with a good methodology that contains a good experiment that has accurate recording and processing of data and of uncertainties. Then a conclusion that answers your research question and it is grounded in scientific context. Then the evaluation should highlight the weaknesses in your methodology and suggest realistic improvements. The recommended timeline for this, and do do listen to me on this because I crammed it all and it was not great. You should start the first half of year 1 brainstorming ideas. Don't really write anything because you probably don't know enough about the topic yet, and that's fine. Then half 2 of year 1, you should pilot the experiment and discuss it with your teachers to see if it has a future. Then in early year 2, you should collect the data and begin writing out the easier sections, yeah. And then by mid-year 2, you should write it out, revise it with your teacher, and hand it in. Please don't do it too late. You're gonna regret it. Well, as an ending note, I wanted to say that this course is designed to be a difficult one. It's not an issue if you feel like you're going through more hardship than the next person next to you. Oh my god, I'm really bad at doing motivational speeches. Or if people in other classes are just having it easier. If you put up consistent effort, you will be fine, and I guarantee you this is one of the more fun classes once you get the hang of it. Though, do use your class and your teacher in order to receive feedback, in order to bounce ideas off of each other. So you can study more efficiently, you can have a community of people to grow with and to have fun with ultimately in those 2 years as you go about IB physics. If you focus on genuinely understanding and having a passion for the subject, the grade will just follow. Good luck to you guys. I'll see you in the next video. Peace.